What's going on, guys? In this video, we're going to talk about ellipses, and it's really just kind of the basic components of ellipses. This particular video is not going to have any numbers per se in it. This is all the theory behind finding the different components of an ellipse. We actually have two different kinds of ellipse too. We have either a horizontal ellipse, which is currently what you're looking at, or we have a vertical ellipse. And all of that starts in this right here. For the two formulas that we're going to look at, we are going to assume that A is bigger than B. And what that means is, it means that A is my greatest denominator. So the location of our greatest denominator is what determines if I have a horizontal or a vertical ellipse. Now, notice that in this particular example, my greatest denominator, which is always going to be referred to as A, is underneath my X variable. Because X has the greater denominator, the bigger denominator, that's going to make me have a horizontal ellipse. So that means that everything that I'm looking at in this video, my vertices are going to be in regards to a horizontal ellipse. My co-vertices are going to be regards to a horizontal ellipse. And then my foci will also be in regards to a horizontal ellipse. Now, with all of that being said, that's the first thing I do. I always look at where my bigger denominator is, because that tells me quite a bit. Next, I find my center. We all know our center. It's very simple. It is simply H, K. So we know that our center is HK. I get that from my formula. And remember, as it's the same with circles, as I pull those H and K values out of the equation, the signs change based on how I graph it, okay? Next, we have our major axes. And our major axes is going to be the longest line in our ellipse. Our major axes is going to be that longest line in the ellipse, okay? The way that we find our major axes is we take A squared. And I'm going to take the square root. Actually, let me back up. I find my major axis. They want oftentimes for us to find the length of the major axis. And the length of the major axis is quite simply 2 times A. Well, what that means is that I have to take the square root of A squared, which that gives me A, and then we do 2 times A. And what that means is the length of this is a length of A, and the length of this is a length of A. And that is going to be extremely beneficial when I'm going to find my vertices. So keep that in mind. All right. So now I can find my minor axis. And my minor axis is going to come from my B squared value. My minor axis is going to be 2B, and my minor axis is the shorter length of my ellipse, okay? And the way that we find the minor axis is I take the square root of B squared, which gives me B, and then I multiply that times 2. Which means that this, from my center to my co-vertices, is going to be a length of B, and then the length from my center to my other co-vertices is a length of B. All right, so remember, that major axis piece, that's a length of A, that's a length of A, and then that minor axis is a length of B, and so forth. That's extremely helpful for me in regards to my vertices when I'm talking horizontal. Now, my vertices are going to be attached to the major axes. My vertices are attached to my major axes. And I find my vertices by utilizing that value of A? Well, if my center is right here at HK, and I am going to move a distance of A this way, the way that I get my vertices, and I'm going to have two of them, is by simply doing H minus A, and K is going to stay the same, and then we're going to have H plus A, comma K. Because that gives me my distance left and my distance right of my center so that I wind up at my vertices. Now my co-vertices are always attached to my minor axis. Again, my co-vertices are always attached to my minor axis. And very similar to the vertices, we always look at my center again. Okay? So with my center, H is actually going to stay the same this time because we're moving up and down when our ellipse is horizontal. So that means that I'm going to have K plus B. H will stay the same, and then I'm going to have K minus B. And that's going to give me the locations of my co-vertices. Okay? The last thing that we have to look at is what's called my foci. I'm going to give myself just a little bit more room with this. My foci is found by taking the square root of A squared minus B squared. And that's going to give me what I call F in terms of foci, right? Very simple. Now my foci are always going to be on my major axes. So since I'm dealing with a horizontal ellipse, that means that I'm going to find my foci by moving left and right from my center. And so if I'm going to be moving left or right from my center, I can follow the same pattern as I do for my vertices, which is going to be H minus F, and K will stay the same because that gives me a distance of here to here. And then we can have H plus F, comma K, and that will give me the distance from here to here. So those are my very generic formulas of how to find each component when I'm looking at a horizontal ellipse. So let's look at a vertical ellipse. So with a vertical ellipse, it's going to be just slightly different. Notice my greater denominator, my larger denominator, is now underneath my y variable. This gives me a vertical ellipse. Okay? Everything is going to be found the exact same way. Remember, my center is still at H, comma, K. That's a very funny looking thing. H, comma, K. So my center is at H, K. And again, we get that from looking at our H and K values. As I pull them out of the formula, what happens? Right on, my signs change. But now, my major axis is now the longer piece of my ellipse. It's still my longer piece, but this time it's going vertically, right? Your major axes will always be following that bigger denominator. It's always going to be following what that A value is. So again, the way that we find our major axes, it hasn't changed. It's still 2 times A. We get that by taking A squared, or whatever that larger denominator is, taking the square root, and then multiplying that times A. And remember that A is going to be very useful when finding what? My vertices. So then we can find our minor axis by taking 2 times B. And again, I've said this a few times, I can find my minor axis. I'm finding the length of my minor axis by doing 2 times B, by taking the square root of B squared, which is my smaller denominator. That gives me B. And then we have 2 times B. When I have those two things, that's going to be very easy for me to use when I'm finding my co-vertices. So my vertices is used with A, and my co-vertices is going to be used with B. So now, remember, the length from here, from my vertices, because my vertices are always attached to what? My major axes. That length is going to be a length of A. And that's why when we say what's the length of the major axes, it's 2A, because there's two of them. And then my minor axis is going to be a length of B. And then my other piece of my minor axis is going to be a length of B, which is why we can say it's 2B for the length of the minor axes. So at this point, I start at H and K. And then when I'm looking at my vertices, now we start at my center, but to go to my vertices, I go along the major axes, so I'm going up a distance of what? Well, it's going up a distance of A, and then we also go down a distance of A. So my vertices are going to be found by finding H, comma, K plus A, and then H, comma, K minus A. Okay? My co-vertices are going to be found now by moving what direction? Well, moving left and moving right, which means I'm going to be changing my H value. And I'm going to be changing my H value by subtracting B and keeping K the same. And I'm going to be adding B and keeping K the same. So co-vertices are always with the minor axes. It's always going to be utilized with B. My vertices are always with my major axes, and it's always going to be utilized with A. And last but certainly not least, we have our foci. And our foci, again, are found by taking the square root of A squared minus B squared. That's going to give me F. And then I take my center, and how am I moving? Well, I'm moving to my foci, which are always on my major axis. And that is going to be a length of what? F. So I'm moving my Y value a length of F to get those foci. So H will stay the same, and then K will be plus F. And then my other one will be H and K minus F. So again, these are our very basic rules of the components for an ellipse. Not too bad. Once you've practiced these, I promise they'll get a lot easier. Do me a favor, if you're a little lost on this video, please check out my next video. Please check out the video of how to graph and how to find these components from an actual problem. I think it'll make a lot more sense. But thanks for checking this video out. I hope it helps. I will see you guys next time.